We were talking about organic chemistry. So basically, in organic chemistry, we deal with the organic compounds, which are hydrogen, carbon, oxygen. But here we will discuss about carbon only. So the question is
Okay,
why we use only carbon as a model? What makes it to be used as standard in all over the chemistry? So basically, carbon is the backbone. Okay, there are millions of
okay,
elements in the universe. Still, carbon is the backbone because we use it as standard. Either it is forensic science to measure the half-life determination, okay, or
uh,
either
okay,
to make different compounds. So here are some properties. First is tetravalency rule. As we know that in the second shell, we need 8 electron to be stable. Okay, but carbon
mm,
has only 4 electron. Total 6 electron. 2 comes in the first shell, but 4 comes in the second and outermost shell. So it needs 4
okay,
electrons to be stable. But
mm,
it has two options, either it takes 4 electron from other element or donates its electron, but what it does, it just share its 4 electron with other elements and make covalent bond. And covalent bond is the mutual sharing of electrons. Okay. Next, what makes it unique? So basically, carbon has properties such as tetravalency, and another property is catenation. Catenation basically,
mm,
when carbon make bonds with itself, like other
mm,
carbon atoms. Okay, this property is called catenation, and with this property, it makes millions and millions of organic compounds that we see in chemistry. And then there are hydrocarbons. Basically, hydrocarbon is a combination of two words like hydro and carbon. Hydro means hydrogen, and carbon is carbon. And there are two types of hydrocarbons, saturated and unsaturated. As we have already discussed, that saturated means stable. S for saturated and S for stability. So it has only one single
mm,
bond, and that's why it is more stable and it is saturated, while other are unsaturated, which are unstable and make double or triple bond, as we see in alkenes and alkynes.
mm,
Then we will discuss about homologous families. So basically, homologous family are the group of elements that share same functional groups and same properties, such as alkanes, the whole group from methane to decane, and in the case of alkenes, ethene to decene. Okay.
okay,
So basically, they share the general formula. In the case of alkanes, it is CnH2n plus 2, where n is the carbon number, and alkenes CnH2n, where it is clearly seen that they have less carbon, less hydrogen as compared
okay,
to alkanes. And in case of
okay,
alcohols, there is a hydroxyl group in the end. Okay.
mm, yes,
Then we will see about alkanes, as we have already discussed that they are saturated, they are more stable, they are inert, means unreactive at room temperature. Okay, their primary source is crude oil fraction, which is petroleum, and it burns efficiently in the presence of oxygen, like combustion when we just use the stoves, and substitution reaction require energy from the UV light.
okay,
Next, alkenes. So basically, alkenes are unsaturated. They have functional double bond, which make them highly reactive. They undergo
mm,
addition reaction in which they take up everything and change into saturated compound with single bond and zero byproduct. Okay, like they
okay,
left nothing. They eat up everything. Okay.
okay,
Now there are some tests to check whether the compound is alkane or alkane. So basically, in alkanes there is a slow substitution, like there is a slow reaction, but in alkanes there is instant reaction. And if we see bromine water test, so basically alkanes are not reactive, so the orange brown water remains orange brown. But in the case of alkenes, the water becomes colorless. And their combustion
Hmm.
profile shows that they burns alkanes burns with less soot, and alkenes burn with highly smoky and sooty flame.
Okay.
The black compound that left after the after you make tortilla, and you see that there is something black charcoal type thing. Okay, that is soot.
Okay.
Now there's other concepts like isomerism, carboxylic acid, and polymers. So basically, isomerism is like same chemical formula but different shapes and forms. Okay,
Okay.
like there are different. They are like in the cyclic form as well, hexane, and they are in single straight chain as well. So they have same chemical formula but different shape and structures, and their properties, their boiling point, their melting point change with their shape. Like straight chain isomers, which have only single bond between them, have the highest boiling point due to increased surface contact. Okay, and
Okay.
next is carboxyl group and esters. So carboxyl group have alcohol at the end, while esters are made when carboxylic acid react with alcohol. Okay, so
Hmm.
esters are basically the product of carboxylic acid reactions. Okay,
Okay.
carboxylic acid have sour taste. All the acid have sour taste. Okay, have you ever tasted apple cider vinegar?
No.
Okay, no problem. So all they have sour taste, but esters have sweet taste. Okay, and this is
Okay.
because of this it is used in cosmetics as well, and artificial flavoring and fruit aromas. Okay,
Hmm.
so these are the properties of esters. So this was all about today's lecture. I know